beautiful people, and welcome. In today's video, we are talking about multiplying and dividing rational expressions. As always, if I make a mistake, I am human. Let me know so that way we can both learn from my mistake and you don't have to make your own. All right, rational expressions. Whenever you see the term rationals, just think fractions. We're dealing with fractions. Now, you are in integrated math 3, so these fractions are going to be a little bit more complicated than what you're used to seeing in, let's say, middle school, in integrated math 1. So these are going to be fractions that have polynomials in them, in the numerator and in the denominator. So multiplying these rational expressions, the steps are the same as if you were to multiply regular fractions. There is just a few little hiccups in the middle just to clarify or simplify a little bit more since we are dealing, with polynomials. But it's pretty much the same. So for multiplying, you're going to factor all numerators and denominators. You're going to note all zeros in the denominators only. Again, excluded values. What can x not be? We're going to find those zeros and then state that x cannot be those because it will make our denominator 0. Once you've factored all numerators and denominators, you're going to divide out common factors. You're going to do common bubbles. Now, the bubbles have to be the same. They have to be identical bubbles. If you have identical bubbles, you get to cross them out from the top and the bottom. You also can cross them diagonally, so you can cross reduce. Again, those bubbles have to be identical. If you have subtraction in between or addition in between bubbles, you can't do it. So that's why it's super important to have bubbles factored, which means you have multiplication in between those two bubbles. Then once you're done simplifying, you multiply the numerators, you multiply the denominators, and you're done. For dividing, we are applying the keep, flip, change, the KFC method. You're going to keep the first fraction, you're going to flip the second fraction, you're going to change the sign to multiplication. You're going to factor numerators and denominators. Make sure that you are noting all zeros in the denominators, and we're writing that as excluded values. So you're writing that as x equals to, x does not equal to, so it's an equal sign with a cross through it, with a dash through it, excuse me. You're going to then divide out identical bubbles or factors, and you're going to multiply the numerators and denominators. Now, depending on if you're working with CUDA, if you're working with, depending on what your teacher says, sometimes you don't even have to factor out, sometimes you don't have to multiply out your denominator. Some teachers will prefer it in factored form and prefer the numerator only multiplied out. Some of them will prefer both of them multiplied out. It's read the directions. My rule in my class is always read the directions. If it tells you that you want it in expanded form, make sure you're multiplying everything out. If it's telling you leave your answer in factored form, then you leave your answer in factored form. All right. Let's do some examples. All right, step number 1, what kind of operation do we have? We have multiplication. So step number 1 in multiplying rational expressions is to factor all numerators and denominators. So let's factor. Here is x plus 5. We can't factor that. Remember, how do we know if we can factor something? Check the exponent on the x. This is 1, this is 1, this is 1. So therefore, we cannot factor further. So then the only thing left to factor is this because I have an exponent of 2. So what I'm having is 4x minus 5. Here I have an x minus 6 times. This is 5 minus 4x. Now, here's the 5 minus 4x. Now, my OCD is kicking in a little bit, so I'm going to rewrite that as negative 4x plus 5 because I don't know, I'm so used to having the term with the x first on the left-hand side, so my OCD kicks in a little bit. You can do that. All right, so then let's factor this. 2 numbers that multiply to 36, but when I add them, give me negative 12. That's going to be x minus 6 and x minus 6. And so once we're done, we're going to divide out common factors. Ooh, before that, I even highlighted it in yellow. Note all zeros in the denominators only. So let's do that now before we start canceling. You have to do this before you cancel anything out because then some of your bubbles will disappear in the denominator, but you still have those excluded values. So here is 1x, here's another x. So what are you doing? In your head, you're setting each one equal to 0. And you're saying what x can't be or what x can be. So in this case, x cannot be So I'm adding 6 to both sides, so x is 6. Now, it's not like you're saying what x can't be. You're saying what x cannot be in the denominator. So x cannot be 6 in the denominator. This is minus 5. So this is 5 fourths, and x cannot be 5 fourths. So once you're done stating your excluded values, you can then simply cross things out to your heart's content. Just make sure your bubbles are identical. So notice here that I have a 6, a x minus 6 bubble and an x minus 6 bubble. Because those bubbles are identical, we get to cross them out. What else do we have? Oh, I see an 4x. Ooh, do you see how this positive 4x minus 5 and this negative 4x plus 5, they're not identical, so we can't really cross them out. Sometimes what you can do is you can kind of be a sly fox and make it work. So we need identical bubbles. So how do I make this negative 4x plus 5 into 4x minus 5? So I'm noticing that if I factor out a negative 1, if I pull out a negative 1, this 4x becomes positive, this 5 becomes negative. So what we can do is you can pull out, you can factor out a negative 1. It's one of those little tricks. I'm going to just rewrite everything here so we have a little bit more space. And then I'm going to recancel out my x minus 6. I did now factor out that negative 1. So it's negative 1 times 4x minus 5. Now I have my bubbles matching up. My x minus 6 bubbles were crossed out already. My x minus 5 bubbles are now matching. And since they are now matching, they're identical bubbles after factoring out that negative 1. We get to cancel those out as well. So what do we have left over? In my numerator, I have an x minus 6 left over. In my denominator, I have a negative 1 left over. So that means I have a negative x plus 6 as my final answer, as my simplified answer. Now, how did I get from here to here? You have x divided by negative 1, and you have a minus 6 divided by negative 1. So that means it simplifies to negative x plus 6. Now, how does your final answer look like? So your final answer looks like this, and your excluded values. You have to have both in your final answer. You're saying, here's the expression simplified. However, x still cannot be 6 and 5 fourths. It will make, like when you graph it, you will see that you cannot have, those are going to be your excluded values. All right, let's do a few more examples. I have x squared minus 2x minus 8, and I have these things. Step number 1 is always factor out numerators and denominators. Again, here's an exponent of 1, exponent of 1. Here's an exponent of 2, so I need to factor that. Here's an exponent of 2, I need to factor that. So again, two things that are multiplying to give me negative 8, but when I add them, give me positive 2. Ooh, what can that be? What can that be? I'm thinking 4 times 4 is 8. 4 times 4 is not 8. Shame on me. 4 times 4 is not 8. 2 times 4 is 8. Ooh, 2 times 4. We can do that. 4 and 2. Because I need a negative 2, I'm going to put the negative on the 4. That's one factor. Now this one here, I have x squared minus 2, so this is where you're using your graphic organizer. I have 2 terms. This one here can be rewritten as x squared minus 3 squared. So that means I have what is it called? The difference of squares. So I have a bubble squared minus bubble squared. So that means my factors are x minus 3 and x plus 3. And then here is x plus 3 on this side and x minus 4. Now I do like to put them in bubbles because I want to see those bubbles match identically. And if they match, we get to cross them out. So I have an x minus 4 on the bottom. I have an x minus 4 on the top. Doing a happy dance because we get to cross those out. What else do we have? I have an x plus 3 on top. I have an x plus 3 on the bottom. Happy dance, getting to cross those out. Now there's one thing I didn't do right now. So what am I left over with? It's x plus 2 divided by x minus 3. Something I didn't do is I did not state my excluded values. So make sure that you're doing your excluded values before you're crossing things out. Because now, if you look at your final answer, You're noticing there's going to be a lot of bubbles missing because you've already crossed them out. You're simplifying them. So what can x not be? This one, x cannot be 3. This is -3 and +4. So this is your final answer. Let's do a few examples on dividing. Again, it's going to be very similar to divide as we were multiplying. It's just a little format different. So what we're doing, looking at our steps for dividing, we're going to apply the keep, flip, change to convert division into multiplication. You're going to keep the first fraction. So we're going to keep the first fraction. You're going to change the second, or you're going to flip the second fraction. In this case, we have x minus 5. It is a fraction with a 1 underneath it. So when we flip it, we make it 1 over t minus 5. And we're going to change the symbol to multiplication. Now we do the exact same steps that we were to when we were multiplying irrational expressions. And that is, you're going to factor. This is an exponent of 1. This is an exponent of 1. So I have only one bubble to factor, one numerator to factor, and that is I can pull out a t. And again, I like to put all of them in bubbles. And let's see if something's going to cancel out. I don't think so. Do you notice how all my bubbles are not the same? Even if I was to pull out, here's a t plus 5. Here's a t minus 1, or excuse me, t plus 1. And here's a t minus 5. Even if I try to factor out a -1, if I factor out a -1, then t becomes negative and 5 becomes positive. Those two bubbles are still not the same. Therefore, there's nothing for us to factor out. So what is it going to be like? How does our answer look like? Well, before we do that, let's check for our excluded values. Anytime you see a bubble or a variable, you're going to say you have excluded values in the denominator. So x cannot equal to -1 and +5, so make sure you have that. And so for our final answer, we just have t squared plus 5t divided by t plus 1 and t minus 5. Again, depending on what your teacher says, read the directions if he or she wants you to factor out the denominator and leave it factored, or if they want you to expand it. Let's do one more. Now this one I wanted to show you because it looks really, 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 really complicated. Trust me, I know how it looks. However, it's not. It really, truly is not that complicated. It just looks that way. This says a divided by a minus 10. This big old line right here, let me actually highlight it in a different color so you can see. You have a fraction, here's your first fraction, divided by a fraction. So it's the same thing that we did in the previous example. We have a fraction divided by a fraction. So how do we deal with dividing fractions? Well, we're going to do the KFC method. We're going to keep, we're going to flip, and we're going to change. And now we have a multiplication problem. Now, again, you want to make sure that you're factoring all things that can be factored. So I'm noticing I have a 2 and a 3, so we need to factor those out. So what do we have? I have a over a minus 10 times, this is the difference of squares, so I have a minus, 10? A plus 10. Use your graphic organizer to find that out. This one might give us a headache because I know I can factor out an a. There's an a in every single term. I don't know why I did that. That's a plus. But then I also need to factor this out further. Two numbers that multiply to -40. But when I add them, give me 6. 4 and 10. 4 times 10 is 40. And we want the 6 to be positive, so that means it is a -4. So here we have a times a minus 4 times a plus 10. Now we get to check for like bubbles. Anything that's the same, we get to cross out. Now, we don't cross them out if both of them are in the denominator. We're talking about crossing these out if they're in the numerator versus if they're in the denominator. You can only do this when you're you can only do this when you're multiplying or dividing polynomials. You cannot do this if you are adding, subtracting polynomials, because then it just works different with being when you have the addition sign and the subtraction sign. These are the same. We get to cross them out. A minus 10. Oh, these are the same. A plus 10, A plus 10. These get to be crossed out. Oh, do you guys see this? I have an A bubble. I have an A here. Now, here's something that I want to point out. Actually, I'm very happy that this happened. Anytime, sometimes this will happen where you will cross out every single thing. That doesn't mean you have nothing. You have something. It's just all simplified out. So when you have everything that's been crossed out, that is equal to 1. So make sure that you have that. So I have 1 times what is left over. Again, do you notice how everything is crossed out in this numerator? That means I have 1. And I have a minus 4 left over. So I have 1 times 1 over a minus 4, which is 1 over a minus 4. Now, again, I didn't do the excluded values. You have to do the excluded values before you simplify. So here is my factored form. I'm looking at all of my a's. So I'm going to have 1, 2, 3, 4 excluded values. X cannot equal to positive 10 here. X cannot equal to 0. X cannot equal to positive 4. And X cannot equal to negative 10. Now, if you wanted to make this pretty and label it from like decreasing to increasing, that would be the correct format of that. I'm not picky. As long as you have all the values, I'm great. All right, beautiful people, that concludes the video on multiplying, dividing rational expressions. If this has been super complicated and very difficult for you to understand, I encourage you to watch more videos. YouTube is a great place for you to watch videos. Ask me questions during class time or reach out to me. I am always here to help. As always, thank you so much for watching my video, and I will see you in the next one. Bye.